In this video, we are going to talk about properties of exponents. So first I have x to the third, and then when they're right up against each other, we know it's times x to the fifth. So when we have the same base and we're multiplying like we are here, what we're going to do is we're going to add our exponents. So I'm going to have x3 times x to the fifth would equal x to the 3 plus 5 would be 8. Again, when I have the same base, I have x here, and now I'm dividing. What I'm going to do is subtract my exponents. So in this case, I'll have 5 minus 2 is x to the third. All right, in this case, we call this power to a power because we have something, a power and a power. And what we're going to do is we're going to multiply our exponents. So I'm going to have 4 times 2 is x to the eighth. Any number to the 0 power equals 1. So no matter what, anything to the 0 power is going to equal 1. Similarly, here we have a power to a power. Keeping in mind this b is technically the first power, so I'm going to multiply my powers. So I'm going to have a6 and b3. Similarly, here we're dividing, but again, I still have power to a power, so I'm going to multiply and multiply. So it'd be 3 times 2 over 4 times 2. So it'd be c to the 6th over d to the 8th. When we have a negative exponent, keeping in mind this is technically in the numerator, what I'm going to do is move it to the denominator and make it positive. Similarly, if I had a negative exponent in the denominator, I would move it to the numerator and make it positive. So we have negative exponent, it's going to change from the numerator to denominator, or vice versa. Oh, they did do one over here. So I have x to the negative 4 in the denominator, so it's going to become x to the positive 4 in the numerator. So we write that over 1, or we just know it's the same as x to the 4th. All right, let's combine some rules now. So I have multiplication. So I'm going to multiply my big numbers. So my big numbers, I'm still just going to multiply. So I'm going to do 4 times 2 is 8. Then I'm going to look for my things at the same base. So I have x to the third and x to the negative 1. So I'm going to do 3 plus negative 1, and I'm going to get 2. So I'm going to have x to the second. Then I have y and y4. Keeping in mind a y is y to the 1, so I'm going to have 1 plus 4 would give me 5. So I'm going to have y to the 5th. All right, here again I'm dividing. So with my whole numbers, I'm still going to divide those whole numbers. So I'm with 5. Now I'm going to subtract my exponents for here. So this gets a little bit tricky because I'm going to have negative 4 minus a negative 2. So that's going to leave me with negative 2. So I'm going to have a to the negative 2. Now, since this is a negative exponent, it needs to go to the denominator. So the 5 is going to stay on the top. My a to the second is going to go to the bottom and become positive. Similarly, in this next one, I have 8 on top and 12 on the bottom. Now, this will not directly divide, but I can simplify this fraction by dividing each of these by 4. So I'm going to end up with 2 over 3. Then I'm going to look at my x's. I have x to the negative 3 over x to the first. So I'm doing negative 3 minus 1, which will give me negative 4. So I'm going to have x to the negative 4. Then I'm going to do the same thing with the y's. So I'm going to have 5 minus 2 would give me y to the third. Now I can see this guy is negative, so he needs to go to the denominator and become positive. So 2 over 3, x to the 4th, y to the 3rd would be my final answer. All right, so again, I have power to a power, so I'm going to multiply, multiply, multiply. So I have 6 to the 1 times 0, x to the 4 times 0, y to the 5 times 0. So I end up with 6 to the 0, x to the 0, y to the 0. Well, each of those are just 1, so I have 1 times 1 times 1 would equal 1. All right, let's take a look at same rules, but now we're going to talk about some fractional exponents. So again, I'm multiplying here. So when I multiply, I'm going to add my exponents. So I'm going to add 1/2 plus 7/2. So remember, when we add exponents, our denominator stays the same when we add the top. And then if we can reduce that fraction, we can, which 8 divided by 2 is 4. So my final answer would be x to the 4th. Don't forget to put the base back in. Here again, I'm multiplying, so I'm going to add. But this time I need to get a common denominator. So if I have 3 and 4, my common denominator would be 12. So to get 12, I'd multiply 3 times 4, and whatever I do to the bottom, I have to do to the top. To get 12, I'd multiply 4 times 3. And again, whatever I do to the bottom, I have to do to the top. So I'm going to have 8 over 12 plus 9 over 12. Again, the denominator stays the same. I'm going to add the numerator. So I'm going to end up with 17 over 12. So x to the 17 over 12. Right now we're dividing, and this looks a little funny, but remember this x on the bottom has a 1. So when we divide, we subtract our exponents. So I'm going to have 5/3 minus 1, which is the same as 5/3 minus 3 over 3. Because again, this would be like 1 over 1. I want to get the common denominator, so it would be 3 over 3. So my final answer would be x to the 2/3. All right, power to a power now, we're going to multiply our exponents. So I'm going to have x to the 2/5 times 10/3. So 2/5 times 10/3. Now multiplying is different. When we multiply the top numbers and we multiply the bottom numbers. So 2 times 10 is 20. 5 times 3 is 15. Then we're going to reduce. So these are each divisible by 3. So I'd have, oh, nope, I meant 5. So 4/3. So x to the 4/3 would be my final answer. So let's do a recap on a little bit of how we do fractions. When we add and subtract fractions, our denominator must be the same. So here's another example. If I have 2/3 plus 4/5, if I have 3 and 5, my common denominator would be 15, because that's 3 times 5. So times 5 times 3. So I'm going to end up with 10/15 plus 12/15 equals 22/15. Versus when we're multiplying fractions, we multiply the numerators together. And we multiply the denominators together. So we do not need a common denominator. So if I was doing 2/3 times 4/5, I would multiply the top and multiply the bottom, so I end up with 8/15.